Hey, how you doing, mate? So let's get started. We have a question right here. They say determine whether the function, we have a step function, determine whether the function fx 1 minus x squared, just like how we see, is continuous or discontinuous, x equal to, and explain why. So we have the condition for continuous and discontinuous, okay? So conditions say, just remember, function, it can be continuous if the domain, if f of b is defined, or in another word, b is domain of fx, and also the function must exist. If it does exist, yes. And how the function is going to exist? Left hand side limit equal to right hand side limit. These are condition for continuous function. The last, okay, now f of x equal to b, and then this, it must be equal to that. Okay, so if they say right, you can just write this information. But for now, so we have to solve it and see if it does exist, and now we can conclude. Now let's go. So now what I'm gonna do, I'm gonna have to find the limit. Okay, let me get the limit first. So I'm gonna start with the limit first. Okay, now, so I can either draw the graph if you want, it's not decided, but let me do both. So what I'm gonna do, I'm gonna say now, let me start with the limit. Limit x approach to what? X at 2 means x approach equal to 2. So limit x approach to 2. Okay, we want to check if it exists. So for what of f of x, okay, we want to check if it does exist. So let me start from the right. So if you start from the right, this let me say, so this let me say, limit x approach equal to 2, but from the right, if you come here careful, look. Which one from the right here, if you look careful? If you say x less than 2, what does that mean? And x is greater than 2. What is that from the right? Okay, so we know for x, the one from the right is this, because if you approach 2 from the right, means you're going to start from 3, 4, 5, 6, means you approach 2. But from the left, you approach 2 means, look here, 2. If any number less than 2 means it's going to be 1, 0, negative 1, negative 2 means this is your approach 2 from the left. But when you say x is greater or equal to 2 means, what that means? 3, 4, 5, 6. So this is a number that you approach 2 from the right. So approach 2 from the right means we're going to check what? This function x squared minus 2. For what for? X squared minus 2. So what does that mean? That means I can plug it in, that value right there. So x equal to 2, plug here is going to be 2 squared equal to 4, so it's going to be 4. Excuse me, sorry. So it's going to be 4, you put here 4, it's going to be 4 minus 2, which equal 2. Oh, so limit f of x approach 2 from the right equal to 2. So we want to do the same thing, limit approach to 2 from the left, and see what we're going to get. You know what I'm saying? So now I'm going to say, okay, so we're going to say limit, but now from the left you say we're going to have to use this one because we approach 2 from the left. Okay, so we say limit x approach 2 from the left, but for f of x. So which function we're going to check? We're going to check this, because approach 2 from the left means it's going to be 1 minus x squared, just like how I explained prior. So 1 minus x squared. So this let me say 1 minus x squared. Okay. Oh, I made a mistake. Excuse me. Here, my apology. This not right here. You know why it's not right? Because this has to be 2x. It's not x squared. So this must be 2x. So this is going to be 4 minus 2. 2 times 2. Okay, so 4 minus 4 equal to 0. So this is going to give us what? 0. I made a mistake. You know what I'm saying? My apology. So this is going to give us what? And 0. Okay, this is going to give us 0 and not 2. Okay, so the answer should be 0. My apology. Just say small error. We correct it. Okay, now, so now we say the one approach 2 from the left. Look, your approach 2 from the left means this is a number. Your 2 But what is x less than 2 means 1, 0, negative 1. So this is the number that you approach these two from the left, because look, just like I explained here. So now we're going to say, so 1, so we're going to say 1 minus, you put 2 square here, 2 square equal to 4. So this is equal to negative 3. Oh, so limit f of x approach 2 from the left equal to negative 3. So what did you see here? Limit from the left is not equal to limit from the right. Okay, so limit from the left is not equal to the limit from the right. So for that case, the limit x approach 2 from the right is of f of x is not equal to limit f of x approach 2 from the left. You know what I'm saying? Or in other way, you can say negative 3 is not equal to the first one to go 0. Okay, so for that case, that's one of the reasons you could say is not continuous, because for continuity means the limit from the left must be equal to the limit from the right. You know what I'm saying? So for that case, I can, confidently conclude and say, no, the function is not continuous, because when you come back here to the question, they say f of x show that either is continuous or it's not continuous at x equal to 2. That's why I did limit x equal to 2 and sketch the graph, so show that. So you know what I'm saying? So for that case, no, it's not continuous. An explanation, because so no, so now we say f of x whereby limit x approach equal to 2, how are you gonna say? Does not exist. Doesn't exist. You know what I'm saying? Does not exist. You know what I'm saying? What I mean? Because there is a condition which has not met. The condition. Which condition? We know the condition of a limit that is not met. Which condition there? Because limit on left. Limit on left hand side, it must be equal to the limit of right hand side, but it is not equal. So for that case, it is continuous. Discontinuous. Is continuous. Discontinuous x equal to 2. You know what I'm saying? So for that case, oh yes, the graph did not. The function, it did not continue x or 2. So now let's draw the graph, because if you come here to the question, there is a question that says sketch the graph of function. Which function? This one right here. So to draw a graph is very, very easy. You know what I'm saying? It's very, very easy. Okay? So how are we going to draw? Okay. Let's draw a graph. So drawing a graph, I can use table value. It's not necessary, but table value is going to make you laugh easily. Okay, or if you don't want, it's fine. So now, So now I'm going to say, let's draw a table value. So I'm going to say, okay, let's draw a table value. So we have here, the face one is 1 minus x squared. So this is the value of x, and y is 1 minus x squared for the face step function. You know what I'm saying? For the face step function. Now we go. What the value of x? When x, they say x is less or equal to 2, means less or equal to 2. So I'd rather start from this side, like saying 2, 1, because less than 2, 0, negative 1, negative 2. I'm not going to do a lot, just some. We know this is quadratic. So now we go. When x equal to 2, what happened? It's going to be 1 minus 2 times 2 equal to 4. 1 minus 4 equal to negative 3. Okay, now we go. So this is going to be 1. 1 is equal to 1. 1 minus 1 equal to 0. 0. It's going to be 1. Okay, now we come here, put negative 1 is equal to 1. 1 minus 1 equal to 0. Now this is going to be 4. So 1 minus 4 equal to negative 3. Now negative 3 is equal to 9. 1 minus 9 equal to negative 80. Okay, negative 15. Oh, okay. So we have the graph of the face parabolic. Okay, which is 1 minus x squared, because f of x is part of the step function. Now let's do the table value of the second one, step function. You know what I'm saying? So now we go, this is x, and what the value of y? X squared minus 2x. X squared minus 2x. You know what I'm saying? X squared minus 2x right there. X squared minus 2x. So this is going to be x squared minus 2x. Okay. Okay. Now we go. So where does it start? It starts from 2 greater than 2. So 2, 3, 4, 5, 6, 7. There's no stopping point, so you can just write it down, whatever you got. So now we say, okay, plug in 2 here. So when you plug it to 2 squared equals 4, minus 2 squared equals 4 equals 0. Now, 3, 9. And this is going to be 6. 9 minus 6 equals to 3. Now we come here. 16, 16 minus 8 equals to 80. Now this is going to be 25. 25 minus 10 equal to 15. 36 minus 12 equal to 36 minus 12, 24. Okay, etc, etc. I don't have to write all of them, but I think you got what I'm saying. So now the next thing is we can draw the graph out of it. So let's come and draw a Cartesian plane right here. Okay, we got all the coordinates. You know what I'm saying? So now we start. Now you gotta be very, very careful, face. You need to know the starting point. This x greater or equal to 2 means that this is going to include it. You know what I'm saying? 2 is going to include it. So we say, oh, so 2 at 2 means this is going to include when x equal to y equal to negative 3. Oh, when x equal to, let's say 1, 2, 2, y equal to negative 3, negative 1, negative 2, negative 3, somewhere here. But it's going to include. You know what I'm saying? Because this sign means including when there are 2. But if it's single like here, excluding. Now we go 1 and 0. 1 and 0. 0, 1. 0 and 1, y 1, okay. Negative 1 and 0, negative 1 and 0, x negative 1, y equal to 0. Okay, now we go 2 and negative 3, 2 and negative 3, 2 and negative 3. Let's say somewhere here. So we see this graph is going to concave like this. Rough sketch. You know what I'm saying? It just go like that. Now let's draw for a second one. So for the second one, we know this is going to concave upward because this is positive. The x squared is positive. Concave upward, quadratic. Now, so which point you started with? The point you started with x equal to 2, but excluding. You know what I'm saying? X equal to 2 excluding. So you gotta look at your starting points. X equal to 2 excluding. Oh, x equal to 2, y equal to 0. So this is gonna be the point here. Excluding means you draw small cycle. But for including, for the first one, you see we draw solid cycle because it was including. You know what I'm saying? So now we go when x equal to 3, y equal to 3. So this 3, and let's say this is 1, 2, 3. Rough sketch, you know what I'm saying? Now we go 480. So this 4 and 80. There's somewhere there. 515. So this graph, remember, is quadratic, so it's going to be parabolic, something like this. It's not in scale, man. You know what I'm saying? But we know it's going to be something like this. Sorry, it's not in scale. Let's say 3 and 3. 1, 2, 3, 3. 4 and 80, 4 let's say 80. So it's like this. It's like, so means not on scale, you gotta be like parabolic like this. So it's not so good because not something like this. Know what I'm saying? Parabolic. Okay, now we go. Remember here, it gotta be empty inside because it was excluding here. Okay, so now we come here now. So we already sketched the graph, you know what I'm saying? And we can prove again using a graph to find our limit from the graph here. They say, show if the graph is continuous. No, the graph is not continuous. You can see here. Because at x equal to 2, you see, this graph is kind of come under and this is on top. So it's kind of disjoint to one another. The only condition this graph could be continuous if this graph was going to start from here also. Maybe go like that. They'll say, yes, the graph continuous. So for this case, like if it had to be continuous, maybe it was going to start from here, or maybe start from like even go now, either way. But you see, it came here and this is disjoint, so it discontinuous. Come on, you don't know continuous meaning means wherever you stop is where you gotta continue. So no, it discontinuous. You know what I'm saying? Why? Because for this quadratic, the one which is concave downward, which is the face one. When x equal to 2, you know what I'm saying? When x equal to 2, excuse me, apologies, 2 here. When x equal to 2, what did it give us? It gave us negative what? Negative 3. See what I'm saying? But at this one, when x equal to 2, it give us what? 0. So can't you see? See here, when x equal to 2, for this graph here, give us what? Negative 3. But here, when x equal to 2, it give us what? 0, y equal to 0. But here, y equal to negative 3. So limit, you know what I'm saying? F of x, when x approach to 2 from the right, What is that from the right? Look, approach 2 from the right to give us y equal to 0. Look, give us y equal to 0 while f of x limit, just normally say limit here, limit, my apology, x approach equal to 2 from the left. Look, you approach 2 from the left. What do you get? Because look, it means you approach, you go and bump this graph of this, which is this one. And which value does it give us? It gives us -3. So 0 is not equal to -3. So for that case, if the limit on the left hand side is not equal to the limit of right hand side, means for that case, say it again, means if this is not equal to this, you know, because this is equal to 0, it means this is not equal to that one. Let me get another pen. Excuse me. So for that case, we say, sorry, because for the limit to exist means the limit, okay, let me write here, limit of f of x, x approach to 2, to exist, for this to exist means limit on left hand side, means from the left, it must be equal to limit from the right. But for this case, since this is not equal to this, means this doesn't exist. You know what I'm saying? And another thing is, we know this is going to be discontinuously, because for the function to be continuously, meaning this is one of the conditions for continuously, means it must exist. So since f of x limit, since, limit x approach equal to 2 f of x, it doesn't exist, means for that case the function is discontinuous. Function discontinuous, man. Continuous. Hey, and you have seen in the graph too, man. For this function, I mean, you can see is disjoint, baby. This one start from there, this one come here. If it had to be continuous, if it was gonna start from here, and one must be including, and one must be this. Like either both must be including, like if this was including and the other one also including, is fine. But if this is excluding and this is excluding, still is not continuous. You know what I'm saying? Or in other way, let me say this. No, that makes sense. So same thing. Okay, if this, let's say, graph come here and then it's also okay, like this one. If let's say come and then exclude here, it is continuous because this one is including. But if both excluding, let's say this one come excluding and this one come also is excluding, then it does not continue because it's empty. So either one of them must be included or both of them must be included, or either one must be included, one excluding. But if both of them are excluding, even if in the same coordinate, still it is continuous. You know what I'm saying? So thanks a lot for your time, man. I hope you learn for how I do things in my methodology. Thanks a lot, thank you. Thanks a lot for your time. I appreciate, man. You know, like I say, you know, we do this in a project to motivate a lot of people, and I truly appreciate your praise and your donation means. I'm Hamish. You know, it's a lot of people who are new here in this channel, you know, in this program, okay? So if you first time right here in these intellectual things, intellectual property, come right here, see here, subscribe and leave a comments. I'm gonna be more than happy to help you. Another thing is, again, I want to say thanks so much for all the people who donated to me, who donated. It means a lot. It's a lot of money you guys are saying to me. It means a lot because you know I got a lot of projects that we're doing, feeding the people, homeless people, motivates, taking all these kids from the street and bring their dream to reality. So thanks a lot for all your donation. It means a lot. Look at most of Sub-Sahara. If I give example, for example, South Africa, a lot of students that have a problem with mathematics, so mathematics and science. And you know, for the world we live in, we need a lot of people who do science and research because of the things like we're facing right now, this year, 2020, like corona and stuff, and people that have a shortage of doctors, that have a shortage of engineers and stuff, and even other causes too. But my main focus is engineering, science, math, and computer programming and coding like Java, C# and PHP and JavaScript. So this is gonna be the main focus. So now we're gonna drop the app very soon. So you can we're gonna put like subscription fees, which is very reasonable, where you can access all the materials. So we're gonna have courses where you can purchase the course. You know what I'm saying? But of course, this is for free, and most of the material here is very accessible. Same with this, but it's light. Some of the course is gonna be for free, and some of the course, depending what type of course. But our main focus is to serve a lot of people, from various places like corporate, you know what I'm saying, the corporate wars. So serve a lot of people, and also going to be traveling, go to various places. So 2020, I'm going to be traveling to a lot of countries. You know what I'm saying? I got invitation, a lot of countries, man. You know what I'm saying? So you gonna see me in your town, in your village. You know, I'm a village boy, so you know I'm gonna go to a village and go see a lot of places, serving a lot of kids, share with them, teach them knowledge, and that can change their life. Okay, that can bring change to our society. Okay, you know what I'm saying? So Pamoja Milali Academy, the app is gonna drop very, very soon. You know what I'm saying? I got a big team. So just stay tuned. I'm gonna announce when the app is gonna be dropped. I believe that most of the people that have a smartphone, so it's gonna be easy for you to access the app. And yeah, you gonna get, I don't wanna say a lot, you gonna see. So thanks a lot for your time.